This is the story of how Penzias and Wilson accidentally discovered the leftover radiation of the Big Bang in 1965. In 1964, Arno Penzias was working at Bell Labs, where he and his colleague John Wilson were trying to build a new type of super-precise radar for the U.S. military. To do this, they needed a radio telescope that could pick up signals across a wide range of frequencies. The larger the antenna, the wider the range. So they built one that was 50 feet across, which was the largest in the world at the time. It consisted of 2,500 individual antennas that would point towards a specific part of the sky and then use a complex process called interferometry to stitch together their signals into one detailed image. This meant that instead of having a single large dish, they had 2,500 small dishes that could be used to make much more precise measurements. The telescope was pointed towards the center of the galaxy, specifically at a region of the sky between the constellations of Sagittarius and Scorpius, and it scanned from a frequency of 1 to 3 gigahertz. Once they had it working, they wanted to test it by trying to pick up a known signal from a source outside of the solar system. They chose a quasar known as 3C48, which was emitting an intense burst of radiation at exactly 4.99 gigahertz. When the results came back, they found a very weak signal at around 700 megahertz, but there was nothing at 4.99 gigahertz. They repeated the experiment several times, even switching to a different telescope, but all they got was a weak, mysterious signal at 700 megahertz. At first, they thought it might have come from a nearby radio tower, but that would mean the signal was thousands of times more powerful than expected. After much deliberation, they decided to investigate further. Since no known object could explain the signal, they started checking every possible source of interference on Earth. The search revealed a nearby satellite whose signal should have matched exactly with the one they had detected, but it didn't. However, they did notice that the satellite's signal was significantly stronger at lower frequencies. This inspired them to try the same frequencies that the telescope had picked up the mysterious signal at. Sure enough, they found a match. The satellite was also emitting a very faint signal at 700 megahertz. It took a few more experiments to confirm, but the signal wasn't coming from the satellite or any other terrestrial source. It was coming from space, and it was everywhere. There was literally no direction in the sky where the signal was not coming from. And once they looked away from the Earth, they realized something astounding. The signal's intensity was identical in every direction. They had discovered an invisible background radiation that was permeating the entire universe. They named it the cosmic microwave background. Since it was faint and only detectable over vast distances, the radiation must have been very old. Either it was emitted billions of years ago when the universe was much younger, or it had been stretched by the expanding universe so much that its wavelength was now much longer than before. But if it had been emitted long ago, why was it still here? All other radiation should have been redshifted so far out of the radio band that it would be impossible to detect. The answer was that it was not being redshifted because it was not moving. It wasn't flying away from us as the universe expanded. It was literally a part of the fabric of space itself. To understand what this meant, we need to go back in time to the beginning of the universe. According to the Big Bang model, everything started out incredibly hot and dense, and then the universe rapidly expanded while continuing to cool. Eventually, the universe cooled down enough for protons and neutrons to form, and then they combined to form the nuclei of the first atoms. Since the universe was still incredibly hot, these nuclei collided with electrons and other particles and absorbed energy until they reached a state of stability. This is the point at which the universe became transparent and light could travel freely through it. Before this, the universe was a thick fog of hot plasma. But after this, it was like someone had removed the lid of a pot. Light could finally spread throughout the universe without being absorbed. But that light didn't look the same as it does today. everything was still extremely hot, meaning that the light was emitted in all directions and at all wavelengths, which is why the universe was white, bright, and incredibly hot. As the universe continued to expand and cool, those photons interacted less and less with matter, and over billions of years, they've been stretched and stretched and stretched. Today, they are millions of times dimmer than when they were first emitted, and they in the microwave band of the electromagnetic spectrum rather than the visible band. The photons themselves haven't changed, though. They're still the exact same ones that were emitted after the formation of the first atoms. Nothing has happened to them since. The discovery of the cosmic microwave background in 1965 was therefore direct proof of the Big Bang theory. It showed that our universe did indeed begin as a hot, dense fireball, but it left many questions unanswered. What caused the rapid expansion in the first place? Why was the Big Bang so hot? How did it start? These questions are still being investigated today. In fact, just a few weeks ago, scientists announced that they had used the cosmic microwave background to map the distribution of matter in the early universe. They found that matter was 10 times clumpier than expected, which could help explain how galaxies formed. The future of cosmology is very exciting. We're living through a golden age of discovery. Every year brings us closer to understanding how our universe began. If you want to learn more about how we're investigating the origin of the universe, check out my video on WEBS, the most powerful space telescope ever built. But before you go, I have a question for you. What's your favorite thing about space? Is it black holes, the Big Bang, or maybe distant galaxies? Let me know in the comments below. I'm the host, this is Minute Earth, and we'll see you next time.